Hello, welcome back to IBEA. I am IB. नाम तो सुना ही होगा. Anyway, we'll be doing Gauss's theorem today.
So Gauss's theorem, let us understand its statement. It states that total flux linked with or associated with a surface. What surface? Gaussian surface. We will discuss later on. Gaussian surface. So linked with a surface is equal to 1 by epsilon naught times the charge inside that surface. Inside that surface. Now, this flux is 1 by epsilon naught times inside the charge inside a surface. That means what? Suppose this is a surface. So there are multiple charges Q1, Q2, Q3, Q4 like this. So total charge Q inside would be Q1 plus Q2 plus Q3 plus Q4 like this. If any one of them, suppose Q3 is negative, so we will write Q3 negative sign. So we understood what is inside, Q inside, that means charge inside a surface, and this surface is Gaussian surface. We will discuss it later on. But what is 1 by epsilon naught? You know the value of epsilon naught. Epsilon naught was given by 8.85 into 10 to the power minus 12. Now epsilon naught has this value only in free space. And this phi is flux. Can we sum up all these ideas like total flux linked with or associated with a closed surface? It has to be closed. Closed surface is 1 by epsilon naught times the charge inside it, where? In free space. So that is what is Gauss's law. And if you go through the statement in your books, you will find this thing. So try to remember it again. Flux associated with a closed surface is 1 by epsilon naught times the charge enclosed by this closed surface. We got an example of this. What is this? Enclosed by means covered. The charges, those are covered by this surface. Is this one thing we did in early videos? That was, we also learned mathematically, this is mathematical expression, and this is not directly Gauss's theorem, mathematical expression, that flux is dot product E and ds, and then I'd put a circle, that means surface integral. That means if we integrate electric field and small areas with dot products for the whole closed surface, that is why this here Gaussian surface is a closed surface. Then we put this symbol and write S, that means surface integral. So surface integral of E dot ds is flux, but according to Gauss, flux should be like this. So we combine these, combining them, we get this formula. Mathematical part, Gauss's theorem. Clear? Now, tell me this, why is Gauss's theorem so important? I'm giving you clues, options. Option 1, Gauss has a very good hat in its picture. Gauss used to dance very well. Number 3, it is very important for exam. And number 4, we get electric field intensity from this. Yeah, right guess. But this is also correct. A very important theorem, this one, Gauss's theorem. You can expect question from this chapter, this part, Gauss's theorem, every year, mostly. So that was it. We get electric field from Gauss's theorem very easily. That is the main thing. Gauss was genius in making tough things easier.